Reduction and oxidations, the two terms are coming from the topic known as redox reactions, and these redox reactions are actually one of the subtopics under chemical reactions. So in this lesson we are going to be looking at oxidation and reduction from redox reactions. Red is talking about reduction and ox is talking about oxidation. Now, when we say reduction and oxidation, what do we mean? So we are saying reduction and oxidation can be defined in terms of oxygen, hydrogen, electrons, as well as oxidation number. So we have four main ways in which reduction and oxidation can be defined. And this is very important because this is actually preparing you for redox reactions that takes place when the process of electrolysis in our chemical reactions is actually taking place. So this is going to lay the foundation for you when you'll be doing chemistry and electricity. So we are going to start with oxidation. What is oxidation in terms of oxygen? Oxidation in terms of oxygen is the addition of oxygen to a chemical substance. We are adding oxygen to the chemical substance. For example, we are having the metal magnesium, which is the sample of a chemical substance. So magnesium is a chemical substance. Now when we add oxygen to this chemical substance to form magnesium oxide, we are going to say oxygen has been added to a chemical substance. Now since we are adding oxygen to the chemical substance, we call that oxidation. So an explanation below, we are saying magnesium has been oxidized to magnesium oxide since oxygen has been added. That is very simple. Example 2, we are having iron 2 oxide. Iron 2 oxide has been oxidized by adding more oxygen to the chemical substance. So this iron 2 oxide is having one oxygen, but we are adding more oxygen to iron 2 oxide, causing it to have about 3 oxygen atoms in one molecule of a compound. And that causes now the ion in the structure to be promoted in terms of the valency. The ion 2 is promoted to ion 3. So this oxidation is in terms of oxygen, but it is also increasing the oxidation number of ion. Ion 2 is being promoted to ion 3 because of the addition of oxygen to the oxide, which is iron 2 oxide. So an explanation below, we are saying iron 2 oxide has been oxidized to iron 3 oxide since oxygen has been added. That is very, very important. So you need to understand, my dear learners, that when you are oxidizing iron to oxide, which is having one oxygen atom, you add more oxygen molecules there, just know that you are going to increase the oxidation number of ion. Ion actually is a transition element. Therefore, when you add a lot of oxygen to the existing oxide of ion, the oxidation number of ion increases from ion 2 to ion 3. That is very, very important. So we are done with oxidation in terms of oxygen. Very important, you can just pick on any metal, you add oxygen there, you understand that that will be oxidation because you are adding oxygen to the substance. Oxidation in terms of hydrogen. The opposite will be our explanations now. The removal of hydrogen from the chemical substance is oxidation. The removal of hydrogen from a chemical substance is oxidation, meaning there we are going to have a compound which is having hydrogen, and when we remove hydrogen from that compound, we call that oxidation. That is very, very important. For example, we are having ammonia. We have ammonia. To nitrogen in ammonia are 3 hydrogen atoms bonded covalently to it. Now, when we break the bonds, in ammonia, and we remove the hydrogen atoms from this nitrogen, we remove hydrogen from nitrogen, that becomes oxidation. And the reason is simple, because hydrogen is a reducing agent. So when we are adding hydrogen to the substance, that substance that is gaining hydrogen becomes reduced. Therefore, when we are removing hydrogen from that chemical substance, that substance is going to be oxidized. For this reason, we are saying ammonia has been oxidized to nitrogen gas since hydrogen has been removed. In the second example, we are having hydrogen sulfide. We react it with chlorine. We are going to have hydrogen chloride plus sulfur. In this case, we will observe that hydrogen sulfide is losing hydrogen, and what is remaining is only sulfur, meaning this substance, hydrogen sulfide, is being oxidized because it is losing hydrogen, and in the process this chlorine is going to be reduced because it is going to gain hydrogen. That is very, very important. Very, very simple concepts. You just need to sit down, understand the concept. We continue. Let us talk about the oxidation in terms of electrons. We understand that electrons are actually located in the energy levels of every atom. Now, every chemical compound is going to have electrons. Every chemical compound is going to have electrons, because every compound is going to be made or created from atoms, and in atoms are electrons. Now, How do we define oxidation in terms of electrons? Oxidation is the loss of electrons from a chemical substance. So when a chemical substance, for example, an atom or an element is losing electrons, we say that that chemical substance has been oxidized. That is very important. You need to understand that. Provided a chemical substance is losing electrons, that chemical substance is going to be oxidized. For example, we have copper. We understand that copper is a metal. And all metals, they react by losing electrons. And when metals lose electrons, they form ions. And those ions are every time positively charged. As you can observe, we are having copper, which is neutral. After losing 2 electrons, it is forming copper 2 positive plus the 2 lost electrons. So we are going to say copper has been oxidized because it has lost 2 electrons. So the statement below, it is saying copper atoms have been oxidized to copper 2 ions since 2 electrons have been lost. That is very, very important. Same applies when we are talking about aluminium. Aluminium is going to be oxidized by losing 3 electrons. Now, I need to explain a very good concept which is actually likely to confuse some of you when you meet that in your exam. You can see that from the examples we are having, excuse me, we are having copper, and immediately from copper we are having an arrow. And there we are having copper 2 ions plus 2 electrons. Okay? This can also be presented like this. We can have copper minus 2 electrons, and we have copper 2 ions. This presentation is same as this presentation down here. This minus I have put here indicates that we are subtracting 2 electrons from copper. So when you see this presentation on your multiple choice, don't say the presentation of the half equation is wrong. No, you need to be smart. We continue. So we have looked at oxidation in terms of oxygen, hydrogen, electrons. Now we are going to oxidation in terms of oxidation number. Now, when we are talking about oxidation number, you need to understand first, what is oxidation number? I think I can just talk about it. Oxidation number is nothing else but the charge that an element is associated with in a compound. The charge. We understand that we may have the charge, for example, we have copper. Copper 2. We have sodium positive. We may have chloride negative. So the numbers, these charges two positive, positive, negative. These are known as oxidation number. They are oxidation numbers. So we are saying the charge that an element is associated with in a compound. We understand that charges only exist in compounds. You need to understand that. A compound is going to have the charge because these charges are equivalent to the valence numbers. And valence numbers are actually combining power of elements. Without charges, compounds cannot be formed. So that is very important. That's the reason why we are saying these charges are the ones that are going to be associated with the independent elements or atoms involved in the formation of the compound. That is very, very important. Sorry. Okay, so now we can start. There are what we call rules to consider when assigning the oxidation numbers. My dear learners, here you need to pay attention and understand. Rules to consider when assigning the oxidation numbers, when assigning the charges. The rule number 1, you need to understand this. The oxidation number of neutral particles, like atoms and molecules, is equal to 0. When you see, for example, in the equation we just have sodium. Maybe this sodium is reacting with chlorine to form sodium chloride. The charge of sodium, since it is just an atom, is going to be 0. The charge of a molecule is going to be 0. Why? Because they are in the background state. They have not lost their valence electrons. They are neutral. Neutral means no charge. That's the reason why we are having examples. We have, for example, copper. Oxidation number will be 0. Sodium, 0. Magnesium, 0. When we come to molecules, we have chlorine molecule, 0. Hydrogen, 0. Oxygen, 0. That is the rule number 1. Understand that. The oxidation number of neutral particles like atoms and molecules is equal to 0. Very, very important. We continue. We go to the rule number 2. The oxidation number of hydrogen in all compounds except metallic hydrides, not halides, but hydrides. Metallic hydrides is equal to positive 1. I want you to understand, my dear learners, the oxidation number of hydrogen in all compounds, apart from metallic hydrides. When we say metallic hydrides, we are talking about the hydrides or the compounds made when a metal reacts with hydrogen, for example, sodium hydride. In sodium hydride, the oxidation number of hydrogen is not going to be positive 1. This is what we are talking about. You will see I am going to cite some examples when I start my calculations. So in hydrides, the oxidation number of hydrogen is not positive 1. But in the remaining compounds, the oxidation of hydrogen will be positive 1. That's the meaning, except in metallic hydrides. But when we are talking about some other compounds like water, the oxidation number of hydrogen will be positive 1. In hydrochloric acid, it will be positive 1. That's the reason why when we are defining an acid, we say the chemical substance which when dissolved in water produces hydrogen ion as the only positively, because in that compound the charge of hydrogen is positive. So the oxidation number in that compound is positive 1. But in hydrides, the oxidation number is negative 1, as we are going to explain where we are going. Take note, you need to change. I think when I was giving you the notes, I changed these halides to hydrides. I remember that. We go to the rule number 3. The oxidation number of oxygen in all compounds except in peroxides and difluorooxides is negative 2. We understand when we are talking about peroxides, for example, hydrogen peroxide. In hydrogen peroxide and difluorooxide, the way it has been presented there, the oxidation number in these compounds, the oxidation number of oxygen in this compound and in this compound here, the oxidation number is not going to be negative 2. No. Mainly it will be negative 1. You need to understand that, my dear learners. You need to understand that. The oxidation number of oxygen in peroxides is negative 1. But the remaining compounds should be positive 2. This is very important when you be doing calculations. Understand that. Rule number 4. For some metals, the oxidation number is equal to the group number on the periodic table or the valency. That is very important. For example, in a group 1, the elements in a group 1, all the elements in a group 1, they have the oxidation number of 1 because the charge or the valence is 1. In a group 2, the same. All the elements who have 2 electrons in the outermost shell, and that calls for a valency, the valence becomes 2. Therefore, when those elements loses electrons, they actually form 2 positive. For example, magnesium to form 2 positive because the valence of magnesium is 2. Sodium will lose 1 electron and form a positive charge. Therefore, the oxidation number of some elements or of some metals on the periodic table are in relation to the valence number. That is very important. Meaning the valence number equals the charge. The charge equals the oxidation number. So it's just the language. Valency, charge, oxidation number. We are just talking about the same thing. We are just talking about the same thing. So that is a rule number 4. Take note. Number 5. The oxidation number of a simple ion is equal to the charge it carries. Simple ions. What are we talking about? This rule is not very different from the rule number 4. Simple ions, we are talking about those elements that are there on the periodic table. For example, we have magnesium ions, calcium, chlorine. Yes. So the valence of aluminium is 3, therefore the oxidation number is 3. Calcium, 2, the oxidation number is 2. A chloride ion is negative, and then we have the oxidation number negative 1. That's very, very simple. So we cannot be wasting time on something very, very simple. We can look at the rule number 6. In a neutral compound, the sum of individual elements present is equal to 0. I can give an example. For example, magnesium oxide is like this. Okay? We understand that the charge of magnesium in this compound, the charge of magnesium is 2 positive. And then oxygen is 2 negative. So these are the charges. Okay? Now we are saying in the neutral compound, this magnesium oxide is neutral because it has no charge. The sum of individual elements present, the sum of the charges of the elements in this compound equals 0. When you add 2 positive as the oxidation number plus negative 2, you will get 0. So this 0 is the overall charge of this compound equals 0. That is very, very important. Every compound which is not having a charge, the oxidation number of the individual elements involved in that compound will be equal to 0. The sum total of the charges equals 0. For example, it's good there are even examples here. Find the oxidation number of sulfur in sulfur dioxide. Okay. Sulfur in sulfur dioxide. You have these examples in your book, but what I want is just to give you the good understanding. Now, we understand that when we have sulfur dioxide like this sulfur dioxide is not having a charge, meaning this rule is stating that in neutral compounds, the sum of individual elements present equals to 0. meaning the charges in this compound, when we add those charges, we should get 0. So, we are going to say the charge of this compound equals 0. Now we are looking for the charge of sulfur. So we are going to say what we are looking for is sulfur. So we will say X, the charge is not known, plus how many atoms of oxygen are there in this sulfur? There are 2 atoms. What is the charge of oxygen in sulfur? -2. The valence of oxygen is -2 equals 0. We are looking for X. +2 times -2 will get -4 equals 0. X equals, we transpose this -4, we are going to get +4, and this is the oxidation number of sulfur in sulfur dioxide. When you leave out the positive, you will fail, reason being that these 4 can be anything, but the indication of positive define that number to be an oxidation number. An oxidation number can be positive or negative. So to communicate scientifically that we are talking about oxidation number, the sign is very, very important. Don't even think that the teacher is going to add a positive for you. Never. So you can see that this is the answer there. What of sulfur in sulfuric acid? Let me go to the whiteboard. We are still looking for sulfur in sulfuric acid. This compound is not having a charge, meaning the total equals to 0. We are looking for sulfur, oxidation number of sulfur. We understand that we have 2 atoms of hydrogen, so we are going to say 2 atoms of hydrogen. The charge of hydrogen in this compound is +1. Sulfur is what we are looking for. We are going to put X. We have plus, we have 4 oxygen atoms times the charge of oxygen in this compound is what? -2 equals 0. So 2 times +1 gives us 2 plus X minus 8 equals 0. So X 2 minus 8 will give us -6 equals 0. X equals +6. So in sulfuric acid, the oxidation number of sulfur equals +6. These are just examples. I can now talk about some of the rules. Let me do some calculations based on the rules. I'll just create a question. Number 1, calculate, or should I say find the oxidation number of a hydrogen, or I start with oxygen in hydrogen peroxide. B, hydrogen in sodium hydride. What else can I add? Maybe I can add this one. C, chromium in dichromate 7. With a charge. Okay. Remember, my dear learners, we talked about a rule which was talking about the oxidation number of oxygen in peroxide, where we said the oxidation number of oxygen in all compounds is -2 except in peroxide. So what will be the oxidation number of oxygen in peroxides? So this is the question. We want to prove it. We want to see if we are not going to arrive at -2. Okay, answers. So A, we have hydrogen peroxide. We are looking for oxygen. This compound is not having a charge, so the oxidation number is 0. We are looking for oxygen. What are we going to do? Okay, we have 2 atoms of hydrogen, so it will be 2. The oxidation number is -1. Is that true? No. +1, then we say plus, two atoms, the oxidation number is not known, so we'll put X for oxygen equals 0. So 2 is the number we are going to get when we multiply 2 times 1, then plus 2x equals 0. We transpose the 2, it will be 2x equals negative 2 over 2 over 2. Let me present the work accordingly. 2, 2. So x here will be negative 1. So in peroxides, the oxidation number of oxygen is negative 1. But in the remaining compounds, it should be negative 2. So you need to understand that. This is what the rule was talking about. Number 2. We go to hydrogen in sodium hydride. Again, there was a rule which was talking about this, which was saying the oxidation number of hydrogen in all the compounds except for metallic hydrides is positive 1. Meaning, in metallic hydrides, it should be something else. Let us prove that. So, we are going to say sodium hydrides. Sodium is a metal. Hydrogen is the one which is known as hydride in a compound. So, in this compound, we just have sodium 1, and the oxidation number of sodium is positive 1 plus hydrogen. The oxidation number we don't know equals 0. So it will be 1 plus hydrogen equals 0, where we are going to say hydrogen equals negative 1. So in hydrides, the oxidation number of hydrogen is negative 1. In the remaining compounds, the oxidation number is positive 1. For example, let me also look at a compound where the hydrogen is going to be positive 1. We can look at this compound, water. Let us look for the oxidation number of hydrogen. Okay, so this compound is not charged, 0. We are looking for hydrogen, so it will be 2 atoms times the oxidation number of hydrogen, which is not known, plus we have 1 atom of oxygen. The oxidation number of oxygen is negative 2 equals 0. So it will be 2H minus 2 equals 0. So 2H equals positive 2. Over 2 over 2. So in water, the oxidation number of hydrogen is positive 1. That is very important. Very, very important. So you can see the difference. The differences in other compounds, positive 1, but in hydrides, negative 1. This is very simple. Chromium in dichromate 7. Now, this compound is like this. It is having a charge. So we are not going to equate this compound to 0 because it is having a charge. So the total charge for this compound is -1 because it is having the charge of -1. We are not going to say 0 because the compound is having a charge. Take note of that. Very important. So chromium, we have 2 atoms in the compound. Chromium is what we are looking for. So chromium, the oxidation number is not known. Plus, we have 7 atoms of oxygen times the oxidation number of oxygen is definitely -2 equals -1. So we have 2 chromium. If you want, you can put X. -7 times -2, you get -14. You get -14, which will be equivalent to what? Which will be equivalent to -1. Oh, pardon me, I think I made a mistake. It should be -2 there. The charge is -2. So allow me to change the charges. So we are saying the charges, the charge of dichromate 7 is -2, so it will be 2 negative, 2 negative, negative, like that. Then the procedure continues, so we are going to say 2 chromium equals -2 plus 14. So what are we going to do? It will be chromium equals +12 over 2 chromium equals +6. Very important. Very important. For now, I'll say goodbye and actually compliment of the seasons. Enjoy the rest of the day.